I'm actually going to probably show you a different way of factoring, an algorithm that sometimes comes in handy. But let's start with this polynomial right here, 6x squared plus 5x minus 4. And let's factor it the traditional, what we call the FOIL method. And the FOIL method, the first thing we do is we look at the first term. And how can I get a 6x squared again? I could get a 6x squared as what, a 3x and what, a 2x. Remember, when we FOIL, we do first times first. 3x times 2x is what, 6x squared. And then we go to the last term, which is negative 4. How can I get a negative 4? Well, I could get a negative 4 is what? Negative 1 times 4, 1 times negative 4, negative 2 times 2. And then sometimes we just try and see what happens. That's why this method is sometimes called a trial and error method. So maybe I put a negative 2 here and a positive 2 here. I know first times first is 6x squared. First times first is 6x squared. And then I know last times last, negative 2 times 2 is negative 4. No problem. We got our 6x squared and our negative 4. What I don't know is O plus my I is, because that's a sum. Sums are harder to see than factoring. So let's just see what our O plus our I is. So our outside times our outside. 3x times 2 is 6x. Our inside times our inside is minus 4x. Can I take 6x and minus 4x and get it to equal to 5x? No, so that was a bad try. And the FOIL method, there are some rules that we could use. For instance, if you notice there's a common factor of 2 here. I knew that couldn't work because there was no common factor of 2's here. So maybe I try a 4 here and a 1 here, and let's see what happens there. This is when I miss chalk, because chalk erases better with your fingers. Okay. All right, so first times first. 3x times 1 is 3x. Inside times inside. Minus 4 times 2x is minus 8x. And I need these to add up to what? 5x. What do they add up to right now? 3x and minus 8x add up to what? Negative 5x. So I'm off on the sign. No problem there. That's a plus, and that's a minus. So that's factoring using the FOIL method. And it is a solid method. It's been taught forever. But now, what's hard to see sometimes is this O plus the I, so it's a little bit of a trial and error method. And we do the trial and error after we try the factoring. So now I'd like to show an algorithm that moves that trial and error up to the front of the process and not towards the end of the process. And to do that, we're going to lay down a little bit of terminology again. And to do that, I want to look at FOILing out this expression right here. So let me just take A plus B, C plus D, and let's FOIL it out. First times first. First times first would be A times C. Outside times outside, A times D. Inside times inside, B times C. And then last times last, B times D. So this is called multiplying. If I misspell a word and you're taking notes, spell it correctly, make me look smarter than I am. Now here, we want to go this way and go back to this with factoring. Well, what I like to do is build what I call a factor box. I'm going to take these 4 terms and I'm going to list them out here. I'm going to have AC plus AD, AC, AD, BC plus BD. Then we're going to use this box to factor. We're going to factor each row. So if you look here, this first row, what do we have common? Well, you see an A in both of them, right? So we could factor out an A. In the second row, what do you see common is a B, so we could factor out a B. This row column here, we see a C in both of them, so we could factor out a C. Here we could factor out a D. And what do we have? A plus B times C plus D, which is what? This right here. So we're going to use a box to factor. And for us, Get that eraser back here. Our problem is this. We're factoring these types of expressions here. We're factoring ax squared plus bx plus c, where a does not equal 0. How many terms do we see here, class? We see 3. How many terms do we need for our box? 4. Oh, so we got to get clever about this. And this leads us to what's called the AC factor theorem. And it says the following. The polynomial ax squared plus bx plus c with a not equal 0 factors if and only if, IFF, shorthand for if and only if, I know how to spell it, if and only if there are two integers, m and n, such that m times n is equal to our a times our c. And our a was what? The coefficient on the x squared, and our c was what, this last term. So they got to multiply to a times the c and add to the middle coefficient. All right. So what we're going to do is we're going to use this concept here to split our middle term into two terms. And that's how the AC method works. Okay, so what's going to happen is, first off, we're going to have to find this a times the c. And I need to keep track of that. And I also need to keep track of the b. So how we do this is just with a little x. Just with a little x. And now there is a handout right there. You can pass that handout out. This is the perfect time for that handout. So we're going to put an x. Up here, what's going to go here is our a times our c. What's going to go here is our b. So we need an example. And let's go back to our first example that we worked. Get my notes out here. So let's go back to our first example. Our first example was 6x squared plus 5x minus 4. So the first thing we do is the a times the c. So we do 6 times minus 4, which is minus 24. And then we got to find two numbers that multiply to minus 24 and add up to 5. So this is my box, my cross, just to help me keep track of this. So I need to find two numbers that multiply to minus 24 and add up to 5. So one's going to have to be positive, one's going to have to be negative. The bigger absolute value is going to have to be what? Positive. So anybody think of those two numbers? How about 8 and negative 3? 8 times negative 3 is what? Negative 24. And 8 minus 3 is what? 5. So what we're going to do now, students, is we're going to split 5x up as 8x minus 3x. We'd agree that that would be equal. So we're going to build our little box now. And what's going to go in our little box? Well, the first term, 6x squared. Then the last term is 5, not 5, minus 4. Right? That was not a minus 4. I think that was a, no, it was minus 4. Hard to tell sometimes with the whiteboard. And then what's going to go in these two is an 8x and a minus 3x. All right, so we have the equivalent. Now we just use each row and each column. 6x squared and 8x. Well, 6 and 8, what do they have in common? Is a factor of what? 2. And we also have what in x? Minus 3x minus 4. Well, first off, there are a few little rules. If you hit a negative in this spot or this spot, you must factor out a negative. And now 3 and 4, doesn't look like there's anything common between 3 and 4, but what number goes into all numbers? 1. So we're going to factor out a 1 there. Then here, 6x squared minus 3x. Well, 6 and 3 have a common 3. X squared and x have a common what? X. Then here, 8x and minus 4. I don't worry about this negative. I only worry if this is a negative. 8x and 4 have a common factor of what? Plus 4. So let's see here. Come over here. What's my final factoring? My final factoring is 2x minus 1, 3x plus 4. And I sense doubt in the room, so let's check. You know, it's kind of like voodoo magic, math magic here. I turned a box into factoring. How did we do that? Well, let's see here. First times first. 2x times 3x is what? 6x squared. Looking good so far. Outside times outside. 2x times 4. 2 times 4 is 8, so I get 8x. Inside times inside. Minus 3x, and then last times last, minus 4. Oh, and what do these add up to? 5x. Oh, and do you see the 8x and the minus 3x? Where do they live in my box? They live, what, right there. So this is just a quick little algorithm. So let's practice another one. Let me get some notes here for my next example. So our next example, let's take 6x squared plus 13x plus 6. And let's do this one kind of together to start with. First thing I do is a times the c. So I do the 6 times the 6, which is what? 36. 6 times the 6. And now I got to think about two numbers that multiply to 36 and add up to 13. So here you are. Thinking hard. There's your brain hard at work. You got to find two numbers that multiply to 36 and add up 13. So go ahead and turn on your number sense there. If you have to, you could come over and write down the factoring of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Do any of those add up to 13? Yeah, 4 and 9 do, right? 4 times 9 is 36, and 4 plus 9 is what? 13. So let's build our box now. By the way, this is where the trial and error comes in. We're doing our trial and error here and not in our O plus our I part. So we're really just trying to find those two numbers. So it still has a little trial and error to it, but it's just up a little closer to the front of the process. So we get a 6x squared. We get our 6. Now it doesn't matter. You can put 4x plus 9x. I could put 4x and 9x. Or I could put 9x plus 4. All right. What was your name again? Peter. Peter, you're the youngest one in the room. What do you want to put here, Peter? 9 or 4? 9. Good. No wrong choice there. All right, so I'm just showing you. I'm working without a net. I did not control where I put that one. All right, 6x squared and 9x. Well, what's common there? 6 and 9 have what? A common what? 3x. 4x and 6 have a common what? 2. 6x squared and 4x. 6 and 4 have a common what? Factor of 2. And then what? We have an x. And then 9x and 6. 9 and 6 have a common factor of what? 3. So what is this factoring? This factoring is 3x plus 2, 2x plus 3. And it just kind of falls apart like that. This is, you might have learned the grouping method or the AC method. This is a very similar method. It hinges off of that same theory. All right, let's do a couple more here since we have time. I like to go through all the possible combinations. Now, the first rule of factoring is to always factor out any common factor. So let's take a look at this one. So on this one here, we have 4x squared plus 2x minus 12. If I dived into my algorithm right now, I would have 4 times negative 12, which is what, negative 48. I'd have to look for two numbers that multiply to negative 48 and add up to 2, which I can do it. It will work. But if I notice 4, 2, and 12, do they have a common factor? They do. Yeah, so we want to pull out that 2, don't we? I see that in the background there. So we get what? 2x squared. 2 goes in the 4 2 times. That leaves behind an x. And that leaves behind a minus 6. We would rather work on this. Why would we rather work on this? Well, what's the a times the c now? 2 times negative 6 is what? Negative 12. I don't know about you, but I am way more comfortable with negative 12 than negative 48. Can we find two numbers that multiply to negative 12 and add up? Oh, if it's not there, it's understood to be what? A 1, not a 0. Can we find two numbers that multiply to negative 12 and add up to 1? So turn on your number sense, and I think 4 times negative 3, I don't need parentheses there. 4 times negative 3 is what? Negative 12. And 4 minus 3 is what? 1. All right, your turn. Factor this completely for me. Go ahead and factor that. Try in the cross this method. I'll give you a second to try that method. Maybe a minute longer. See a few pencils still going. All right, so let's go ahead and work this. I imagine most of you put a 4x here and a 3x minus 3x there, right? I tried to flip mine around just to show you that it will work the same. All right, so how many of you got a 4x right here? Raise your hand with pride that you put a 4x there. How many don't want to play the game today? Raise your hand. All right, so you put a 4x there, I put my 4x there. Let's see if we get the same answer, just in a different order. So 2x squared minus x, nothing in common but what? N x. 4x minus 6, well 4 and 6 have a common what? 2. 2x squared and 4x, well there's a common x to begin with, and 2 goes into both of them, so I can pull out what? A 2. Minus 3x and minus 6. So if this is negative, I got to pull out a negative, and 3 and 6 have a common factor of what? 3. So what's our final factoring here? 2x plus 2, 2x minus 3. And remember, the order of your factors does not matter. So if you had 2x minus 3 and x plus 2 in different order, you're going to get what? The same product in the end. All right. So now we have looked at when the end is negative. We've looked at when the middle is negative. What haven't we looked at? What happens when the first term is negative? So now let's look at our next possibility. What happens if A is negative? So let's look at minus 6x squared plus 5x plus 4. All right, if you told me to factor this using the FOIL method, what would I do? First thing I would do is factor out that negative. It is so hard to factor with negative. So the first thing I would do is I'd factor out the negative. I get 6x squared. When I pull out a negative from positive, I get minus. Pull out a negative from positive, I get another minus. And then what would I do? I would run my algorithm on that piece, what, right there. So if A is negative, you don't want to try factoring. Trust me, it gets confusing. You want to factor out that negative, and then what? Factor this. So let's go after this factor. So what are we going to have? Our A times our C. 6 times minus 4 is what? Minus 24. So we're looking for two numbers that multiply minus 4 and add up to what? Minus 5. So turn on your brain there again and think about two numbers that multiply to negative 24 and add up to a negative 5. So the bigger absolute value is going to have to be negative. Let's see. I think we've seen these two numbers before. I know 8 times 3 is what? 24. And I know minus 8 plus 3 is what? Minus 5. So let's split this. And we'll split it right over here. What are we going to split it as? 6x squared. I get the minus 4 here. 6x squared minus 4. And then what is this going to be? Minus 8x plus 3x. All right, I'll give everybody a chance to get caught up. And then I see that most of you like to play along. So I'm going to let you try to pull out the common factors there for me. Give me a minute longer. Okay, so let's do these. I don't want to make anybody late for class, including myself. 6x squared and minus 8. Well, 6 and 8 have a common factor of 2, and x and x squared have a common factor of what? X. So I'm going to get what? 2x. 3x and minus 4, there's nothing common. Oh, there's always something common. What's always common? A 1. Yep, there's no x there. All right. 6x squared and 3. Well, 6 and 3 have a common 3. And then x squared and x have a common what? X. Minus 8. Oh, I see a minus, so I know I got to have a minus. 8 and 4 have a common factor of what? 4. So this will factor as, we still have our minus 1 there. We have 2x plus 1 times 3x minus what? 4. And if you doubt, you could always check. We know the first times the first is 6x squared. We know the last times last is what? Minus 4. You could check. This is what? 3x. This is what? Minus 8x. Have we seen those two terms before? Yeah, or 3x and what? Minus 8x. All right. So this is an algorithm. This is not the FOIL method. This is not the AC method. But it's an algorithm that I will have to admit I stole it off of a former student here many years ago. It was taught in Evanston High School. I wished I would have asked what the name of it was because he didn't give me a name. So, but I stole it off there and mastered it, and I find I can get my students to do this when they're struggling at factoring any other way. So, all right, questions. I'll open up for questions. And didn't think there'd be a lot of questions on a math talk, so like this time. So, all right, well, thanks for coming along. And, oh, Rhonda. Oh, practice problem? You want another one, Rhonda? I'll give you two. I have more made up. Yeah. I'll give you, so here's two practice ones. And now I'll even give it so it works. Plus 19x plus 12, 8x squared plus 22x plus 15. Do you want the answers? Or not?
I'll come to you later.
Okay, I won't give you the answers then. But there are a couple of practice ones, so. And sorry, thank you.